Okay, so definite integration using U substitution. This is AP Calculus AB. And we're going to find the area of this function right here, the definite integral from 0 to 4 of 1 over the square root of 2x plus 1 dx. I'm looking at this also, so I'm looking at this piece right here, and I'm comparing it to this piece on top. And I'm asking myself, is it possible that this piece up here is any part of the derivative of this? Well, the slope of 2x plus 1 is just 2, isn't it? And 1 is a number. There's no other variable attached to it, so possibly this is possible. So what I'm going to do is this. I'm going to use this thing called U substitution. I'm just going to make a let statement, because I have to describe to my reader what I'm doing. So I'm going to let U equal 2x plus 1. I think we can agree that the slope of this line, du dx, which just means the slope of u with respect to x, is equal to 2, isn't it? Can we agree on that? Here's a line. The line is 2x plus 1. The slope of that line is 2. Okay. But this is what I want. So I'm going to just do a little bit of algebra. And what I'm going to do is this. See this dx right here? I'm going to try to replace it with this dx. So if you just did some algebra here, you would find out that dx is equal to du over 2. Yeah? Now I'm going to rewrite this function. I'm going to rewrite the function in terms of u instead of terms of x. So as I rewrite, I'm going to take the definite integral from 0 to 4, right, of 1 over what? Square root. That's right, square root u. Now, here's what I was trying to say to you before. I was concerned about this dx because we'd have a u and an x, right? So instead of doing that, I'm going to replace dx, because it says dx is du over 2, so there's our du over 2. Right? Now I'm asking you to buy this, that du over 2 is the same as 1/2 times du, isn't it? That 1/2 is called a constant multiplier and can be brought out. So there's your 1/2 right there. Here's your definite integral from 0 to 4. Right? We also, hopefully, we can agree that 1 over square root of u is the same as 1 over u to the 1/2 power, right? And we know if we have an exponent in the denominator, it comes up as a negative exponent, right? So we have is equal to u to the negative 1/2 power. So we end up with u to the negative 1/2 power times du. Right? This is what we were looking for. This is what we were hoping to get. We were hoping to get this integral, g of a to g of b, of f of u du. F of u means what is the function? This happens to be a square root function, doesn't it? And u is its derivative here. So we have that. Now we can start to integrate. When we integrate, all we're going to do is this. We're going to add 1, right? We're going to add 1 to the exponent. And negative 1/2 plus 1 is positive 1/2, isn't it? So we're going to get 1/2. Because we're starting to integrate, we're going to take down the integration sign. Remember I told you that that symbol is saying what we intend to do. So now we're going to go ahead and do it. So u to the 1/2 over 1/2. But this 1/2 comes up as 2, doesn't it? Isn't that true? This comes up like this, Harrison? Right? So this comes up like this as 2, doesn't it? Is that making any sense? But look, when we started out, we had 0 to 4, didn't we? But the function was in terms of x. This is our lower limit. This is our lower limit here. This is our upper limit. So we have to go back, and we said at the beginning that u was equal to what? It says u was equal to 2x plus 1, right? So 2x plus 1. So it says here we had 0, so 2 times 0 plus 1 is still 1. So our lower limit is still 1. But now we need this upper limit, and it's 2 times 0 is, I'm sorry, 2 times 4 is plus 1 is 9, right? All right, see if you can see this for just a second. 1/2 times 2? Speak up. 1/2 times 2 is just 1. So we have square root of u, right? U to the 1/2 square root of u as evaluated from 1 to 9. And then we're going to use this thing called the fundamental theorem of calculus, which just said that we don't have to do all this adding up of this area. We can just do this. F of B minus f of A. F of B, so square root of B minus the square root of A. Square root of 3 is, square root of 9 is 3, yeah? Square root of 1 is 3 minus 1 is 2. So the area under that curve is 2. Yes?